All right, we're going to talk about S5A, S5B, S5C, kind of an introduction to relations, functions, domain and range, and vertical line tests. So we're going to start off with a warm-up, and we're going to construct a Voronoi diagram between sites -2, 5 and 4, 3. So the very first thing I did was I drew the 2 points. Here is point A, and here is point B. Then, so the very first thing we do is we found the midpoint. So halfway between here and here is the midpoint. We can use the midpoint formula, which is the average of the x values divided by 2, and the average of the y values divided by 2. So that midpoint formula gives me this value here. Oh, there you go. Might want to hit pause to see that. Okay, so then I look here and I find the slope. So it goes down 1 over 3, down 1 over 3. So my slope is -1/3. So my perpendicular slope is going to be the reciprocal and the opposite sign. So the perpendicular slope is going to be 3. So that means I go up 3 over 1. And you can see this line here would be perpendicular to, if I drew a line right there, this blue line is perpendicular to the red line. Okay, so now I use the point slope form equation. I can plug in the slope of 3 into the equation, and I'm going to put in the midpoint, which is 1, 4, and I put those values in, and then I get my equation. Okay, so let's talk about relations. So a relation is a set of ordered pairs, okay? And if you look at this relation here, we want to find out what is the domain and what is the range. So whenever you're trying to figure out the domain, it's basically a list of the x values. So our x values are 6, 12, 18, 24 in this example. The range here is the y values that we have. So 8, 12, 15, 18. Okay. You might want to hit pause if you need to copy this down. Okay. Now, to test if something's a function, we can do a function map, and we'll do some examples of that later. But another way to quickly determine if something's a function is to use something called a vertical line test. So if I use a vertical line test, that means I can draw a vertical line anywhere through the function. I could draw the line here, I could draw it here, I could draw it here. It doesn't matter where you draw your vertical line. But the important thing when you're doing the vertical line test, if it only goes through the function once, then it is a function. And you can see in this example here, the vertical line goes through the equation twice, so that means it's not a function. So in these examples, you could see the pink example here. I've got 1, 3 and 1, 7. These two have 2 different y values for a single x value, and that gives you the similar situation. You might want to hit pause or rewind to think about that or hear it again. Next. So on all these examples, I drew vertical lines, and you can see that in all the ones that say yes, the vertical line only comes through the graph at one spot. Here, the vertical line goes through the graph in 2 spots, and same thing here. And now, H is an interesting question. Let's look at it more closely. So wherever you have circles, if I draw this line through this part right here, at this blue line, the function is at this dot. So At this point, it's still a function. At this point, it's still a function. It's only right here that it makes it not a function, because if I draw the vertical line through here, it goes through this dot and this dot. So if I hid this part and this was my only function was this part here, then this would be a function. But because of this vertical line that goes through two dots, that makes it not a function. Okay. Question 3. This is an important question, I would say. Will a graph of a straight line always be a function? And the answer is no, because if you draw a vertical line, that won't be a function. A vertical line can't be a function because there are more than one places where the vertical line goes through a vertical line. Okay. All right, next. So here we've got this funny notation here. And basically this is saying, look, we've got f of x equals 2x squared minus 3. Okay. So I've got my function here. I can plug in 5 in place for x, and then I end up with my answer. Here I plug in negative 4 in place of x, and then I get my answer. So my input value is 5. My output value is 35. All right. So let's look at this next part. Here we've got this equation here. For this example, f of negative 1 represents the value of y when x is negative 1. Find f of negative 1. We substitute negative 1 in the equation in place of x, and then we get 3. So this gives us the point negative 1 comma 3, which is this dot right here, and it lies on the function. So what is the value of f of 0.5, and how would you find it? So to find the value of f.5, I'm taking my function, I'm taking that function, and I'm replacing x with 0.5. Okay, and then I end up with 2 times 0.5, which is 1, and 1 plus 5 is going to give me 6. So this means that when x is 0.5, y is going to be 6, and that is right here at 0.5 comma 6. Okay, you might want to hit pause. Okay, so consider this function, find the value when f of 2. So basically plug in 2 in the equation. Now when it says find the image of this, this textbook is basically saying we want you to find f of negative 1. I don't know why they use the words image of, but this is what they wanted you to do. Okay, question C, determine whether 0.5 comma 26 lies on the graph. So basically I'm going to plug in 5 into my equation. I've got 5 squared plus 1, which is going to give me 6. So when x is 5, y is 26, so the answer is yes, this lies on the graph. Let's look at the next question. Okay, so they've given you this equation. The price in dollars of a motorcycle T years after purchase is modeled by this function. Okay, so the independent variable is T, which is the value that we have here, which is represents time. My dependent variable is P, which is the price that we get when the time as it changes. Okay, so A was to find the independent and dependent variables. Question B, find the value of P of 0 and state what that means. So basically I'm going to plug in 0 in place of T, and we end up with getting 15,000. So basically what does that mean? This is the price of the motorcycle when you purchase it at time 0. Okay, question C, find the price of the motorcycle after 1.5 years of the purchase. Plug in 1.5 in for T, and we get this value after 1.5 years. Okay, question D, find the value of T in which P of t equals 6,250. Interpret what this means. So basically, the P of t is this value. So what we're doing is we're saying, okay, this is what we're going to make 6,250, and we're going to solve for t. So what do I do here? I subtracted 15,000 on both sides. Okay, and then I get this value, and then I divide both sides by negative 2,500, and we get this. Question E, comment on the case where t equals 0. T equals 6. So if I plug in 6 in for t, we end up with $0. So basically, my comment is the price of the motorcycle after 6 years is $0. I doubt the motorcycle is worth $0 after 6 years, but that's what this equation would say. I don't think it's a good equation, if you ask me. So how are we going to sketch a graph? Well, we know that at time 0, it's worth $15,000, and we know after 6 years it's worth nothing. So I can just draw a straight line between those 2 points. Okay, so you're given this function, and you got t parentheses d, gives you the average temperature in terms of d of days of the month. Explain what the meaning of t parentheses 2 equals 25. So basically this says the second day of January, the temperature is going to be 25 degrees. You might want to hit pause and think about this. On question B, state the domain of the function t. So the domain is the x values, or the d values, which is our independent variable. So there's 31 days in January, so the domain is going to be 1 to 31. Now this part's important. Basically it's saying d is an element of integers, because you're not going to have 1.5 days on a calendar. It's going to count by integers. Okay. Question C. Given the data in this table, estimate a reasonable range for the function here. So my range is the y values, or the capital T values, and you look here, and the lowest value is 20, and the highest value is 28. So a range of temperatures is going to be between 20 and 28, and that's probably a good reasonable estimate of what my range might be. Okay, and this is saying that our function t is elements of real numbers. You're not going to have any imaginary values for temperature. Question 2. Consider f of x equals 10 minus 4x. The independent variable is x. Calculate f of 2. So basically we're plugging 2 into the equation. F of negative 1/2, I plug in negative 1/2 into the equation. Question C, show that f of 2.5 equals 0. I plug in 2.5 in place of x, and then we show that it's equal to 0. There is an x for which f of x equals negative 6. Find the value. So the answer is yes. I'm going to plug in negative 6 in place of f of x, and then we subtracted 10 on both sides, divide by negative 4, and here we go. Okay, let's look at question 4. Okay, so here's a graph, and it says write down the value of f of negative 2. So when x is negative 2, y is going to be 5. And when x is 6, y is going to be negative 3. Okay. Find the value of x that justifies this. So when y is 3, x is going to be 0, when f of x is 0. So this is basically saying when y equals 0, right there, so we're going to have an x value of 3. Okay. Find the set of x values for which f of x is less than 0. So this is saying y values have to be less than 0. So when are the y values less than 0? When the x values is greater than 3. You might want to replay this and think about this one for a minute. And basically, x has to be an element of all real numbers. Okay, let's graph these lines. So y equals x plus 1. My slope is 1, and my y-intercept is 1, so it's a little bit raised. Y equals x. There's my equation. Y equals negative x. I've got a negative slope. X equals 1, negative 3. Y equals 4. Of all these graphs, all of them except for this one is a function. The vertical lines can't be a function. Okay, almost done here. Okay, so here's a graph of cell cultures, n, a number of cells, versus t hours. Okay, so the relationship represents the graph of function. Give the reasons why this is the case. So this here is a function because it passes the vertical line test, and there's also, you could also say, there's only one y value for every x value. Okay, question B. State the independent variable and the dependent variable. So the independent variable is our x value, which is time. The dependent variable is our y value, which in this case is the number of cells. Question C. Estimate the initial number of cells in the culture. So right at the beginning, the initial value, it's going to be, when you look at the graph, it's 5 cells. Okay. And then estimate the value of n when t equals 4. So if I go time to t equals 4, I can see that the value looks like it's 8. Okay, let's look at the next one. Estimate the value of t when n equals 32. So if I go n equals 32, I kind of go over and down. And so when I go to 32, I go over and down. So it looks like the time is going to be 12. When n is 32, I go over, the t is going to be 12. Okay, estimate the interval time over which the number of cells varies from 64 to 128. So 64 to 128 is between here and here. So at 64, I go over and down, and it looks like it's at 16. And 128, I go over and down, and it looks like it's 20. So to go between 64 and 128, my x values would be 16 and 20. You might want to rewind and think about question F again. Okay, and then lastly, find the range of the function. So the range is the y values, and the range is between 5 and 100 and 1. Is this right? The range is the y values, and it goes between 5 and 128. 128. Okay. And then let's do question 7, and then we're done. Okay, so the cost of renting a car is given by this formula, where C is the cost in dollars and K is the distance traveled in kilometers from the pickup point. Find the cost of renting a car for 30 kilometers. So I'm going to plug in 30 in for K, and it's going to cost me $300. Find the value of C of 72. I plug in 72 in for T, and I find the cost is going to be 510. And question C. A group of friends rent a car and pay this amount of money. They go to Reyes, a village which is K kilometers from where they pick up the car. Determine the distance between Reyes and the pickup point. So here we know that, so let's start off with the equation. C of K equals 150 plus 5K. So in this example, they've told you the cost. The cost is 1,275 equals 150 plus 5K. So step 1 is I'm going to subtract 150 on both sides. And then I'm going to get 1,125 equals 5K. And then the last step is I'm going to divide by 5. So to make that cancel out. And then I'm going to get the K equals 5 goes into 11 2 times, carry the 1. 5 goes into 12 2 times, carry the 2. 5 goes into 25 5 times. And so this units for this is in kilometers. So determine the distance between Reyes and the pickup point is 225 kilometers. And that is the solution for this handout.